everybody, this is video 432. That is our second video for our third standard from Unit 4. And we're still working on this. We're working on writing and interpreting quadratic models. This time we're going to be focusing on the interpreting part of that. So we're going to be using these quadratic models that we've got and kind of understanding the parts and the information that they can provide about a certain situation. So it is lots of word problems here, and we're going to have to kind of get down and start to understand what they can produce. And that starts with understanding what the variables mean. So when you're ready, let's get going. All right, make sure you've got your graphing calculators because we're going to have to be substituting numbers in here and doing some different type of evaluating, so you definitely want a calculator with you. It doesn't have to be a graphing one, you just got to have a calculator available. All right, so the first one is we're given the height of an object. Now remember, we've talked about this before. This negative 16 t squared is talking about the force of gravity. This next one is our initial velocity. So that's our, I called it v sub 0, our initial velocity, the speed at which it's being released at. And then this last piece is the initial height, our h sub 0. So where does it start? So the first question actually says, what is the initial height of the object? Now let's suppose you get to an assessment and you're like, I don't remember that it's the last term of the quadratic, it's plus h sub 0. All right, well, if the initial height of the object, initial meaning when time equals 0, it means when it starts. So why don't we just find h of 0, meaning why don't we just substitute in a 0? Remember, h of 0 means substitute in a 0. Just like f of 4 means substitute in 4, h of 0 means substitute in 0. So I get negative 16 times 0 squared plus 40 times 0 plus 150. And believe it or not, everything cancels except the 150. So my initial my initial height is 150 feet. What is the height after 3 seconds? Well, that's telling you that t equals 3. So what do? H of 3. We substitute in 3. So here's where you're probably going to want to use a calculator. So go ahead and grab it and let's figure out what h of 3 is. We substituted in 3. I got, after 3 seconds, it's at 126 feet. At 126 feet. Did you get that? Okay, what is the maximum height? Well, the maximum height of this object, okay, the height is, and this is important, time is the x and h of t is the y. So I want to know what is the y value at which this is its highest. Well, if you kind of picture what's happening here, this object starts at 150 feet above the ground and it goes up and it comes down. So the maximum is actually asking for the vertex. But I don't want the x value of the vertex, I want the y value of the vertex. So we have to find it. Well, to find the vertex, we learned from our graphing portion, was that we took the opposite of the b and divided it by 2 times the a. That's how we found the x value of the vertex. We substituted that in and we found the y value of the vertex. So let's go ahead and try that. Negative 40 over 2 times negative 16. So let's just calculate that. So negative 40 divided by negative 32 gives me a positive. Time equals 1.25. And I can never round here. I have to use the entire time value or I won't be getting an accurate height. So now I have to substitute in h of 1.25. And this is going to tell me the maximum height. What does the 1.25 mean? It means that after 1.25 seconds, this object reaches its maximum height. That's how long it takes from the time that it's launched or shot or thrown or whatever, kicked, who knows. That's how long it takes to get to its height. To find the height, we have to substitute. So go ahead and try that. It's going to be negative 16 times 1.25 squared plus 40 times 1.25 plus that 150, which is the initial height. Go ahead and give it a shot. I got 175 feet. 175 feet is the highest this object will go. All right, another one. This one, as you can see, is a little bit different. It does not have an initial velocity. In other words, this was just dropped. Okay, nothing was pushing on it or pushing it up or pushing it down. It was just let go from 25 feet up. So my initial height is again when t equals 0. So negative 16 times 0 squared plus 25 gives me an initial height of 25 feet. I have no idea why my pen just got thinner. Next one, find the height after 5 seconds. Negative 16 times 5 squared plus 25. Let's see. Negative 16 times 25 plus 25. This is a negative 375 feet is the height after 5 seconds. What could that possibly mean? How could we interpret that? Well, we are allowed to go below sea level. So if 0 just represents the ground or the sea level, and this object starts at 25 feet above, and it's just dropped, well, then at some point it could go below sea level. What if it's into a canyon or something, for example, or into the water, for example? Let's find the maximum height. Remember, the maximum height comes from the h of t value of the vertex. So we have to find the vertex. The vertex is found by using the opposite of b over 2 times a. That is 0 divided by 2 times negative 16, which means 0. Well, we already found h of 0, so this maximum height is 25 feet. Its maximum height is also its initial height. Okay, this one's a lot different. Let's take a look and read it. This is finding the maximum price. The profit from selling local ballet tickets depends on the ticket price. Using past receipts, we find that the profit can be modeled by the function p equals negative 15x squared plus 600x plus 60, where x is the price of each ticket. So we have x is the price of the ticket, comma p is the profit. So we have ticket price, comma profit. I think it's really important to know what your variables represent so that as you're solving, you're answering the questions appropriately. So it might be a really good idea to write this down. It doesn't take a lot of work and it's really going to help most of you out in the end. We want to find the ticket price. Ooh, that means we're finding an x value that gives the maximum profit. Well, that's the y value. And also find the maximum profit. Well, maximum, just like it did when we talked about the height of an object, is the vertex. So we're going to calculate the vertex. And when we find the x, we're finding the ticket price. And when we substitute it in, we're finding the profit. So we use the opposite of b over 2 times a, and then we substitute that in. Negative 600 divided by 2 times negative 15. Let's just get that right. So that is negative 600 divided by negative 30. We should get 20. So 20 is the best ticket price. Okay, so we're finding the best ticket price, and that's going to produce the maximum profit. So now we're going to substitute that in. So I have negative 15 times 20 squared plus 600 times 20 plus 60. Go ahead and take a second to do that. All right, so I got the profit to be $6,060. So let's really examine what this means. This means that, remember, this is a flipped over parabola, and it starts at $60. So I'm just kind of showing you what it looks like. So the maximum is at $20 per ticket, and we reach a maximum profit of $6,060. So that answers the two questions. But let's think about why. Why is there a perfect ticket price that produces the most money? Well, if it's too cheap, then maybe we won't make enough money. But if it's too expensive, no one's going to buy them and we're not going to make enough money. So this is really a very logical business situation in which there is a best price to choose for for a product or a service that's going to give you the most profit. All right, now we got another one. We've got a maximum population. So similar, we're looking for maximum. The observed bunny rabbit population on an island, I don't know why, is given by the function p equals 0.4 t squared plus 130 t plus 1200, where t is the time in months since they began observing the rabbits. So the population is p. So we have time in months, comma, population. So my x value is my time in months, and the population is the number of bunnies. So what is the maximum population attained? When? I didn't even read that one. When? So when is the time? So find the x value. What is the maximum? That's the y. So this one finds x, this one finds y. And when does the bunny population disappear? When is the population equal to 0? All right, let's start with part A. So we're going to take the opposite of b divided by 2 times a. All right, negative 130 divided by 0.8. So it looks like I forgot a negative sign. Let's put a negative sign out front here. This won't work otherwise. All right, so let's try that again. Negative 130 divided by negative 0.8. There we go. 162.5 months after it's being started. Now it doesn't ask us to convert that into years, so we're not going to. So 162.5 months. Now, what is the maximum population? Well, then I would have to substitute in that 162.5 squared plus 130 times 162.5 plus 1200. All right, give that a shot. All right, I got a maximum population of 11,762.5 rabbits, or bunnies, or bunny rabbits. All right, now that's not logical to have the 0.5, so we're going to get rid of the 0.5 and just call it 11,762. So that answers, looks like my battery's low. So that answers question B. And the last one is, when does the bunny population disappear? And this is when we set it equal to 0. And we would have to use the quadratic formula. So I'm going to make that part, because it isn't part of this standard, I want to make that part actually one of your try these. So that's a solving one, and I want you to use the quadratic formula to answer part C. And in addition to that third part where I want you to use the quadratic formula, I would like you to try this one, which is about Custom Bike Company. And just go ahead and try that one, and we'll get to talk about that the next time I see you.